Hello and welcome to the video for 1-4. Our learning target is I can divide like, and we're really not doing unlike bases. We took that out. Like bases with exponents. Okay, so before we get to the notes, let's just remember what we've done already. Okay, when we've had 5 to the 6th power times 5 to the 2nd power, we did this a couple days ago. This is a multiply problem. So we keep our base and then we add the exponents. 6 plus 2 is 8. Okay, so multiply problems mean add the exponents. So today we are doing problems that look like this. 5 to the 6th power divided by 5 to the 2nd power. So this is a divide problem. Okay, and since multiply and divide are opposites, add and subtract are opposites. So our answer, 5 to the 6th power divided by 5 squared, is 5 to the 4th power. Okay, so when it's multiplying we're adding, but when it's dividing we're subtracting, and that's our lesson for today. Okay, well, if it's in fraction form, we're subtracting our exponents. Numerator, NUM is numerator, minus the denominator. Denom means denominator, just abbreviated a little bit there. Okay, so we've got 8 to the 5th over 8 to the 3rd. And let's switch colors to a darker color here. That makes 8. 5 take away 3 is 2. Let me show you this another way. If we do expanded form. Let me show you something. That means I'm going to have 8, 8, 8, 8, 8, expand it all out on top. On bottom, I'm going to have 8 times 8 times 8. Okay? If I have something on the top of the fraction and something on the bottom of the fraction, then they cancel each other out. So I have 2 8s left, so that makes 8 squared. Okay? If I was doing the next problem, let me move this over a little bit. Okay? I was doing this problem right here. Keep my base. 2 take away 5 is negative 3. But remember, I have to make that 1 over 10 to the positive 3rd power. Let me show you another reason of why that happens. So if I write expanded form, on top I would have 10 times 10. And on the bottom I would have 10 times 10 times 10 times 10 times 10. And just like we did with the 8s over here, if I see it on top and bottom, it cancels. Well, everything on top canceled. So I've got to replace that with a 1, because it can't be nothing. And on the bottom, I have 10 3s, 10 to the 3rd power. Okay? Now the expanded form, you don't have to write that out. But I want you to see it so you understand what's going on here. Okay? It's a little bit harder to do the expanded form with exponents, so it's best once you understand the concept of the expanded form, then that helps you realize why we subtract exponents. Then we can just apply our law of exponents of subtracting here. Okay? So my base stays the same. And then I am thinking to myself, okay, negative 3 subtract 2. Okay, so a lot of students have trouble with the exponents when you have positives and negatives involved and subtracting and adding and yada yada yada. Okay, a couple things. Either just type it into your calculator, -3 take away 2. I know some of you may be thinking, I should know that without a calculator. Well, that may be, but I'd rather you got it right. So type it in if you need to. Or you can think about it in terms of money. Anytime you see a negative sign or a subtract sign, that's money you need for something. I need $3. Let's say -3 represented money I owe to Mrs. Smith, and subtracting 2, that's money I want to spend on a soda machine at the teacher's lounge. So if I need $3 for Mrs. Smith and I need $2 for the soda machine, then I need $5. Okay? Or you can think about it like temperature. If my temperature starts out at -3 degrees and subtracting means the temperature gets colder, so it goes down by 2 degrees. Well, 2 degrees colder than -3 would be -5. All right, so again, we need to put this in final answer form because it has a negative exponent, so 1/7 to the 5th. Okay? Sometimes problems will be written horizontally with the division bar. You're going to subtract your first exponent minus your second exponent. So keep your base. 8 minus 5 is 3. And you're done. The next one, keep your base. 2 take away 4 is -2. Now, a student in my first period class pointed out that their strategy is that once they have this part written, they're doing their work in pencil, they put the fraction bar and the 1 on there, and then they erase the negative sign in front of the 2 instead of rewriting everything. And that was a strategy to kind of save some time and save some writing. So that's totally up to you. Okay, you can write both and just circle this as your final answer. All right, here we've got 8 as our base. Now here again, we got some negative integers here, and I really want you to think through, use a strategy so that you don't make an error. My subtraction that I'm doing in my head, so I'm going to draw a thought bubble here, is -3, -2, and I'm subtracting them. So if that's hard for you, if you're not sure it should be positive or negative, you're not sure it should be a 5 or a 1, I really encourage you to type it in the calculator to get the right answer. Okay? But if you're not doing that, if I have subtracting a negative, that's like 2 negatives in a sentence or 2 negatives in math. 2 negatives next to each other, 2 of these signs, one of them's negative, one of them's subtract. They kind of cancel each other out and they make a plus. So this would be the same as -3 plus 2. So this would be the same as I owe Mrs. Smith $3, but I have, plus means I have $2. So once I take these $2 and I pay Mrs. Smith, I will only owe her $1. Okay? Now you can go back and do this little trick where you put the fraction bar in the 1 and erase the negative, or you can rewrite it 1/8 to the 1st power. Your choice. Okay? Negative bases and fraction bases. The only thing that makes this look more complicated is these have parentheses. Well, don't let that throw you. The parentheses are there because negative bases and fractions have to have parentheses around them. Okay? It holds the negative and the 5 together, and it holds the 8/5 together for the exponent of 9 to apply to the whole fraction. Without the parentheses, the 9 would only go to the 8 instead of the whole fraction. So this answer, keep the -5 in parentheses, And then 16 minus 7 is 9. Keep the negative 7 in parentheses, and then 10 minus 3 is 7. Same thing with fractions. Keep your fraction in parentheses, and 9 minus 2 is 7. Keep your fraction in parentheses, and 6 minus 3 is 3. Okay, so don't let the parentheses throw you. Also, going back to these negative bases, notice I did not make fractions out of these. That's because it's the base that's negative, not the exponent. The exponent's positive. We only make fractions with negative exponents. Okay? Now, one thing that I promised I would talk about, and I'm going to put it as a little Easter egg in our video, is we talked about a couple days ago that any number to the 0 power equals 1. And some of you gave me a look like I had 3 heads when I said that. You were sure that it had to be 0. Well, now that we've had today's lesson, I can explain to you why things to the 0 power is 1. Let's say I had 5 divided by 5. I think we can all agree that anything divided by itself is 1. Okay, let's talk about 5 squared divided by 5 squared. Okay, so if we put that in standard form, that would be 25 over 25. That's no exponents in it. And if we just look at 25 over 25, we know that that's 1. And it really all comes down to anything divided by itself is 1. Anything divided by itself. I could put a whole series of, I could make a fraction if I said a squared b to the 4th c to the 9th and a squared b to the 4th c to the 9th. Okay, I've used all kinds of letters, all kinds of exponents. But the fact is the top and the bottom are exactly the same. So no matter what A, B, and C are, if you divide something by itself, by the exact same thing, then the answer is 1. Going back to our exponents though, our laws of exponents. Okay, if I follow along with what we did in class today, 5 squared over 5 squared, that's a division. Keep the base. 2 take away 2 is 0. So if we've already decided that something divided by itself equals 1, and if this answer of 5 to the 0 power, if this is equal to that, those are equal, then 5 to the 0 power has to also be equal to that. And if you really want to impress me, the reason that we call that true is called the transitive property. Whoops. The transitive property, it means if I set up a little chain here, we'll set up a little chain. So 5 squared over 5 squared equals 25 over 25 equals 1. That equals 5 to the 0 power. Everything in this little chain, we can put an equal sign under. That means transitive property means that I can pick any 2 things in the chain and say that they are equal to each other. Okay, any two items in the equals chain, and I can set them equal to each other. I can set this equal to this. Okay, so anything to the 0 power equals 1. Next up, let's do some homework help. Okay, we've got your homework here. And we're going to look at the directions. The directions say to leave your answers in exponential form. So we're not going to be doing any calculator work that involves the caret key or anything like that. So number 1 says 4 to the 9th over 4 to the 6th. So keep my base of 4. And 9 take away 6 is 3. And so that one's done. Okay, let's skip down to number 4. 4 is a negative base. It looks more complicated, but it's not. Just keep my negative 4 base in parentheses. And 2 take away 1 is 1. Fractions, number 13, same thing. Looks tougher than it is. 1/2 in parentheses, and 7 take away 3 is 4. And lastly, let's look at number 14 because it has some negative integers in it. We got to be careful. Okay, so we got 5 as my base. And I recommend anytime you're really not sure, it doesn't hurt underneath the problem to write down the subtraction that you're trying to do in your head. -2, -6, and I am subtracting them. So you can type this into your calculator. Remember that this is the subtract key, this is the negative key. You can rewrite this as -2 plus 6. Combine those two double signs. But at the end of the day, you need to have a 4 here. Not a -4, not an 8, not a -8. So be careful about that. Thank you for watching. Have a great day, and I will see you tomorrow.